Good morning friends, welcome back to Panika Tutorials. In this video, I want to discuss one more numerical question on round robin scheduling algorithm. This kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Four processes such as P1, P2, P3, P4 with their arrival time and burst time calculate the average normalized turnaround time using round robin scheduling algorithm with time quantum as 2 units. In the question they have provided as normalized turnaround time of a process is a ratio of turnaround time over the burst time. They have given four options. We need to solve the question and find out what is the right answer. We know how to compute the turnaround time of each process, which is completion time minus arrival time. But they have defined normalized turnaround time as turnaround time by burst time. If we can compute the normalized turnaround time of each process, we can easily compute the average normalized turnaround time. This is what they have asked. Is it clear? Now, as the given question is related to the round robin scheduling algorithm, we need to take the ready state and running state. So let me take the ready queue, running, and the Gantt chart. Always the Gantt chart will start from 0 units of time. At 0 units of time, process P1 has arrived to the ready queue. As the process P1 is there in the ready queue, it will be scheduled to the or dispatched to the running state. Process P1 needs 9 units of CPU time to complete its task, but it is a round robin scheduling algorithm which is a preemptive scheduling algorithm with a time quantum of 2 units. So process P1 need to run for 2 units of time. So its remaining burst time is 7 units. By the time process P2 has arrived at 1 unit of time and process P3 has arrived at 2 units of time. Now process P1 will be dispatched from running state to the ready queue back. Okay, process P1 we run for 2 units of time. Now next process which is there in the ready queue is process P2, which will be dispatched to the running state. So process P2 will run for 2 units of time. Okay, so its remaining burst time is 3 units. Process P4 has arrived to the ready state at 3 units of time. Now, once the time quantum is completed, as it have remaining burst time, process P2 will be sent back to the ready queue. In the queue, next process is P3, so it will be scheduled to the running state. Process P3 will be run for 2 units of time. Okay, so its remaining burst time is 1 unit. As it has the remaining burst time, process P3 will be dispatched to the ready queue. Is it clear? Are you able to understand or send back to the ready queue? Now you need to look at any other process came. Only 4 processes are there. So no other process came. So we have kept the process P3 after the process P2. Okay. Now in the queue, process P1 is there. So process P1 will be dispatched to the running state and it will be run for 2 units of time. Okay, so its remaining burst time is 5 units. So it has the remaining burst time. Process P1 will be sent back to the ready state. Okay, now in the queue, next process is P4, so it will be sent to the running state and process P4 will run for 2 units of time. Its remaining burst time is 2 units. As it has the remaining burst time, process P4 will send back to the ready state. Okay, now process P2 is there in the queue, so process P2 will be sent to the running state. Okay, process P2 remaining burst time is 3 units, however the time quantum is 2 units, so it will run for 2 units. Its remaining burst time is 1 unit. Is it clear? Are you able to understand? As it has the remaining burst time, it will go back again to the ready queue. Now in the queue process P3 is there. Okay, now process P3 will send back to the running state or dispatch to the running state. Time quantum is 2 units, but however process P3 needs only 1 unit of time. So process P3 will run for 1 unit of time. It has completed its requirement, so it will go to the terminated state. So process P3 will send to the terminated state, so we no need to keep back in the ready state. Is it clear? So process P3 has completed its task. Now in the queue process P1 is next, so it will be scheduled to the running state. Okay, its remaining burst time is 5 units, however time quantum is 2 units, so process P1 will run for another 2 units of time, so its remaining burst time is 3 units. Is it clear? Are you able to understand? So as it has the remaining burst time and its time quantum is completed, again we will send back that one to the ready state. Now in the queue, the next process which is available is process P4. Process P4 remaining burst time is 2 units and time quantum is also 2 units. So it will run for 2 units of time. So its remaining burst time will be 0 units. So process P4 also completed its task. It will go to the terminated state. So if it goes to the terminated state, we no need to keep it back to the ready queue. So next one is process P2. So process P2 will be sent to the running state. Even the time quantum is 2 units, process P2 needs only 1 unit of time, so it will run for 1 unit of time. Its remaining burst time is 0 units, so it will go to the terminated state. Process P2 also done. Okay. Now process P1 is there. It will run for 2 units of time. Okay, and will be sent back to the ready queue, and then again it will be there in the running state because only one is there. So process P1 will run for one more unit. So at 21 units of time, process P1 has completed its task. Okay, so all the process has completed the task by 21 units of time. If you have a doubt, you can verify. 9 plus 5 is 14. 14 plus 3 is 17. 17 plus 4 is 21. So all the process burst time completed is at 21 units. So this is what we got. So now we can compute the completion time of each process by looking at the Gantt chart. Process P1 has completed at 21 units of time. Process P2 has completed at 18 units of time. Process P4 has completed at 17 units of time. Process P3 has completed at 13 units of time. So we got the completion time of each process. Now we can compute the turnaround time of each process. Turnaround time is completion time minus arrival time. Okay, we have the completion time and arrival time of each process. Now we can compute the turnaround time, which will be 21 minus 0 is 21, 18 minus 1 is 17, 13 minus 2 is 11, 17 minus 3 is 14. Now we need to compute the normalized turnaround time. Normalized turnaround time is turnaround time by burst time, which is 21 by 9, 17 by 5, 11 by 3, 14 by 4. Now let me compute these values. 21 by 9, which will be 7 by 3, okay, which will be equal to 3 2s are 6. You will have 1 by 3, which will be 2.333 something. Is it clear? Are you able to understand? And 17 by 5. 17 by 5 is how much? 5 3s are 15. Okay, you will have 2 by 5 is 0.4, so which is 3.4. 11 by 3, 3 3s are 9. Okay, you have 2 by 3, which is 6 something. Okay, are you able to understand? It is 14 by 4, which is nothing but 7 by 2, which is 3.5. So normalized turnaround time of each process, we got these values. Now we need to compute the normalized, okay, Average normalized turnaround time. So average normalized turnaround time is equal to sum of all the four process normalized turnaround time by number of process, which is equal to 2.33 plus 3.4 plus 3.66 plus 3.5 by 4, which is equal to, okay, compute the sum, 2.33, 3.40, 3.66, 3.50, which will be 9. 3 plus 4 is 7, 7 plus 6 is 13, 13 plus 5 is 18, okay. So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 4 is 12. So you got 12.89. Is it clear? 12.89 by how much? 4. You compute it. 12.893, okay. This is, if you consider it as 8, it will be 2. Am I right or wrong? Is it clear? So it is around 3.22. Okay. So option A they have given as 2.34 is wrong. Option B is 3.45 is wrong. Option C is 3.67 is wrong. Option D 3.22 is right. So the right answer for this question is option D. I hope you have understood how I solved this question. If you still have any doubts related to this question, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.